आज का हमारा चैप्टर है नंबर सिस्टम। नंबर सिस्टम एक ऐसा चैप्टर है जो हमने अपने पुराने हर क्लास में इसके बारे में पढ़ाई की है। हर नेक्स्ट क्लास में कुछ नए कंसेप्ट्स ऐड होते चले जाते हैं। तो आज का हमारा टारगेट ये रहेगा कि हम एक बार बेसिक लेवल पर जो भी हमने प्रीवियस क्लासेस में पढ़ाई की है उनको एक बार रिवाइज़ कर लें और नेक्स्ट वीडियो से हम क्लास 9 के सिलेबस की ओर आगे बढ़ेंगे। तो हमारे पास जो पहला टर्म आता है नंबर सिस्टम, कि नंबर सिस्टम क्या होते हैं। तो नंबर सिस्टम इज़ अ मेथड टू रिप्रेजेंट numbers using symbols और डिजिट्स। सो ये एक बेसिक डेफिनेशंस है। इसमें एक टर्म और ऐड होता है जो कि हमको बताता है रूल रिलेटेड विथ इट्स ऑपरेशंस। ऑपरेशंस क्या क्या होते हैं नंबर सिस्टम से रिलेटेड, जैसे हमारे पास एडिशन है, सब्ट्रैक्शन है, मल्टीप्लिकेशन है एंड डिवीज़न है। तो इस ऑपरेशन से रिलेटेड रूल भी नंबर सिस्टम के अंदर में आते हैं। तो ये हमारा बेसिक नंबर सिस्टम का डेफिनेशंस हुआ। हमने प्रीवियस क्लासेस में इन नंबर्स के बारे में भी पढ़ाई की है, नेचुरल नंबर, होल नंबर एंड इंटीजर्स। तो नेचुरल नंबर्स क्या होते हैं, हमने अपने नेचर्स में हमेशा काउंटिंग करने के लिए इन नंबर्स को यूज़ किया है, जैसे कि 1 2 3 4 एंड इट गोज़ अप टू इन्फिनिटी। सो नेचुरल नंबर जो होते हैं उनकी काउंटिंग 1 से चालू होती है। इसी सीरीज़ में हमारा दूसरा नंबर है होल नंबर, जिसके अंदर नेचुरल नंबर्स तो सारे आते ही हैं, जिसमें एक 0 एक्स्ट्रा नंबर होता है इस सेट में, जो कि हमारे इंडिया के मैथमेटिशियन आर्यभट्ट ने इसको डिस्कवर किया था, जो कि बहुत यूज़फुल होता है बड़े नंबर्स के कैलकुलेशंस के लिए, बड़े नंबर्स मल्टीप्लिकेशन डिवीज़न के लिए। लेकिन इन दोनों नंबर्स में नेगेटिव नंबर्स को ऐड नहीं किया गया। क्यों नहीं किया गया? क्योंकि उस समय नेगेटिव नंबर्स के बारे में उतनी अवेयरनेस नहीं थी। धीरे धीरे चलकर लोगों के बीच, देश के बीच ट्रेड बढ़ा, लोगों ने एक दूसरे से लोन लेना चालू किया, लोगों के ऊपर डेट चढ़ा, जिस कारण से नेगेटिव नंबर्स की रिक्वायरमेंट बढ़ी और हमारे पास नेगेटिव नंबर्स के कंसेप्ट चालू हुए। और इसमें देख सकते हैं कि नेगेटिव नंबर्स टोटल्स हैं, साथ में 0 है और ऑल द पॉजिटिव नंबर्स इसके अंदर आते हैं। तो इसमें जो नेगेटिव नंबर्स हैं इनको हम नेगेटिव इंटीजर्स बोलते हैं, और जो पॉजिटिव नंबर्स हैं उनको पॉजिटिव इंटीजर्स बोलते हैं, और 0 इसमें इंक्लूडेड है। तो हम देख सकते हैं कि इंटीजर्स के अंदर ये जो नंबर्स हैं ये सिमिलर होल नंबर जैसे हैं, और बाकी इसमें नेगेटिव नंबर्स भी ऐड हो गए। लेकिन अभी भी हम एक चीज़ देख सकते हैं कि रियल लाइफ में हमें कुछ ऐसे नंबर्स का यूज़ करना पड़ता है जिसको हम इन तीनों नंबर्स के थ्रू नहीं रिप्रेजेंट कर सकते हैं, जैसे कि नंबर 2.5, 3.9, 2.1 एंड ऑल द डेसिमल नंबर्स। सो फॉर दिस देयर वाज a need to have certain number set which will have all these decimal numbers, the fractions number and every numbers in between. So there was a concept for decimal expansion. So when we divide, let's say example, if we divide 10 by 2, we get the answer 5. But when we divide 5 by 2, we get 2.5. There is a decimal place. What about dividing number 10 by 3? You get something like 3.33333, and it goes on. So they start repeating itself. There are certain numbers whose division will give you like 2.434343 and so on, or it may be like 3.125 dot. So we can have numbers like which are full multiple of certain number, or it is in fraction. It might be there might be repetition of a single number, double number, triple number, but all these number are rational number. So let's understand it by understanding about the decimal expansion. So as we read about this concept, that we know that decimal expansion can be in form of terminating numbers, or it can be non-terminating. In terminating case, and we get this value. For non-terminating, we get this or these numbers. So for non-terminating, there are additional two numbers. It might be recurring numbers or repeating, as we discussed in this one, that there are after certain digit they get repeated. It may be one number repetition, two number repetition, three number, four number, whatever may be the case. And we can have non-recurring numbers. Or non-repeating. So these numbers which are non-repeating and non-recurring are known as irrational numbers, and every numbers terminating, recurring, repeating are called rational numbers. So we can see it by saying that rational numbers are the numbers which can be written in terms of p by q. Here we saw that if we divide certain numbers, we get decimal expansion, decimal number, or in expansion form, and this is also a rational number. Let's see how. So the rational number can be written in terms of p by q, where p and q are integers, but q is not equal to 0. Why q is not equal to 0? Because you can't divide any number by 0. Okay, so it can't be 0. So what about irrational numbers? Irrational numbers are the numbers which can't be written in terms of p by q. We saw that irrational numbers are the numbers which are non-terminating and non-recurring in nature. So what are those numbers which are non-terminating and non-recurring numbers? We can see the example of pi, which value is 3.1415926535, 8979 and so on. It goes up to several trillions digit and still counting till date. So there is no end of this number. There are numbers like root 2, root 3, root 5. You can calculate these numbers and you will get similar expansion without any end. And you can also see that in this example that there are no relation between numbers. You can't predict the next number from its previous number. But in case of this number, we can predict what will be the next number. Similar in this case, similar in this case. So irrational numbers are the numbers which can't be written in terms of p by q, and its decimal expansions never end, and it is in terms of non-terminating and non-recurring numbers. So we can now conclude that there are only two types of number in this world. For our as per our syllabus, that we can say that real numbers are the set of all rational number and irrational number. We will also learn the complex numbers in future, but for now we have rational number and irrational number, and it is called the real number. So we can understand this by seeing it visually. That let's have a circle for natural number, a circle for whole number, for integer, for rational number. So we can see from our previous discussion that natural number are like 1 2 3 4 till infinity. Okay, in case of whole number, all the numbers in natural number and one extra number which is 0. So all natural numbers comes under whole number. It can be written in terms of like 0 and n. What about integers? For integers, we studied that it might be negative, it may be 0, it may be positive numbers. All negative, 0 and positive numbers comes under integers. We can also see that positive numbers are like natural numbers. 0 and positive numbers combined comes under whole number, and extra and negative numbers under integers. So all whole number comes under integers and all natural number comes under whole number. So what about rational numbers? Rational numbers are the numbers which can be written in terms of p by q, where q is not equal to 0. So all integers come under rational number. Why? Let's take example of 2. It's a integer, we know that, but it can also be written in terms of 2 by 1. Same for any integers, you can write by 1, dividing 1 you will get the rational number. So every integers comes under rational number, but all rational numbers like 5 by 2 is a rational number, but it is not integer. Okay, so every integers is a rational number. What about irrational number? Irrational numbers don't cover any of these, so we have to give it a separate circle. Irrational numbers are which can't be written in terms of p by q. So one major circle is required. Now this is the real numbers, which is a set of all rational number and all irrational number. Okay, so from our concept till we understood about the number system, we understood about the natural number, whole number, integers, decimal expansion can be of terminating, non-terminating. Okay, terminating or non-terminating. In non-terminating it can also be recurring type or non-recurring type. These non-terminating and non-recurring numbers are called irrational numbers. So we understood that p by rational number can be written in terms of p by q, where p and q are integers and q can't be 0. So for it irrational number, it can't be written in terms of p by q. Why it can't be written in terms of p by q? Because its decimal expansion is non-terminating and non-repeating. If you can't know the number what will be its end, how you can divide p by q? So it can't be written in terms of p by q. And for real numbers, it is a set of all rational number and all irrational number. So it can be easily understood about the relation between those numbers, that at basic level there are natural number, which comes under whole number, which comes under integers, and it all comes to rational number. And there are a separate set of numbers, irrational number, which come under a real number. So it's a basic concept and you should have this knowledge. Let's discuss some common problems a student come across, that are integers rational number? Let's take, is 2 a rational number? Is 3 a rational number? Is 4 a rational number? Yes, it is a rational number, because 2 can be written in terms of 3, 2 by 1, 3 can be written in 3 by 1, 4 can be written in terms of 4 by 1. So these all are rational number. Some student can ask why root 2 is not a rational number, because root 2 can also be written in terms of root 2 by 1. Anyone can ask, but to define a number we should have in terms of p by q. For any numbers to be a rational number, it should be in terms of p by q, where p and q are integers. Okay, so it should be a full number. You can say that if is root 4 by 2 is root 4 by 1 is a rational number? Yeah, it is, because for root 2 and root 1 we get the value for root 2 we get a value of 2, and for root 1 we get a value of 1. It's 2, so it's a rational number. So at its basic level we have to calculate we have to simplify its the number to get its the smallest form. If it can give integers, so it's a rational number. If it can't, it's not a rational number. Some students have doubt about, we learned in previous classes that pi is equal to 22 by 7, and here we studied that pi is a irrational number and it can't be written in terms of p by q. So why we are writing here 22/7. So the value of pi is not equal to 22/7. You have to understand that, because if we divide 22/7, we get the value like we can see that here we get the value 2, but in actual the value of pi is 3.1415926535. So 22/7 gives 2-digit approximate the real value of pi, but what about other numbers? So it won't give the infinite numbers or any numbers correct for after 2 digits. So its value is not equal to 22/7, but it is used to make our calculation easy, because in circle chapter we will see that in many cases the radius is given 7. So we take this and our calculation gets easy. So the value of pi is not 22/7, but it's used for making our calculation easy. There is one more question among students: what about 0? Is 0 a rational number or not? So ये क्वेश्चन आप लोगों के लिए है। आप इसका जवाब मुझे कमेंट सेक्शन में बताइए, और हम लोग कोशिश करेंगे नेक्स्ट चैप्टर से क्लास 9 के सिलेबस को चालू करें। सो आपको अगर इसका नोट्स चाहिए मैं डिस्क्रिप्शन बॉक्स में डाल दूँगा, और आप लोग तब तक के लिए इसको एक बार अच्छे से रिवाइज कर लीजिए। थैंक्स एवरीवन।